Yeah. Okay. Good. So we're going to start looking at uh, the topic of statistics. Right? Um, as a matter of fact, statistics, we could never do any kind of justice to uh, the topic of statistics in this short time, right? Statistics, as a matter of fact, is a whole branch of mathematics that we can never, in even one whole semester now, be able to really introduce and open up statistics to you, the students, you know. But I'll see what I can talk about in this little time, right? And basically, what statistics is all about is that whole process of collecting data, and you don't just collect data for no reason. Lots of times, the reason for collecting the data is to understand or to study some characteristic of a certain what we call population, right? I'll probably give you some examples. Y'all know they used to do a thing in Guyana here. They do it on to know, called census.
Yes, sir.
Yeah. Well, census is really statistics. You're collecting information about the population of Guyana to know what's going on, you know, how are people faring in terms of, you know, housing, their salary, um, you know, all those things you can find out.
There's like a bunch of characters of a person.
Well, it's not, it's the characteristics you need, right?
Yes, sir.
Sometimes they
Correction,
do
characteristics.
registration as well. You know, they do registration for election. That again
Yes, sir.
is collecting statistics about the people. How many people are eligible for voting, right? When we speak of the population, right, don't get it wrong. And that's what I'm saying. For us to really get into statistics, we have to really spend a lot of time with it, right? Population doesn't have to be a whole country, right? This class that is doing the what's this course? Math proficiency course. You can be viewed as a population, right? And well, we are small numbers, just about 20 people. So there might be no need to take out a sample from that. But lots of times when you want to understand a population, you might not have the kind of money that government has. You know, they do census, you know what millions of dollars they have to spend to do census. But most of the time you might not have that kind of money, you know. So what you have to do is take a sample, a representative sample out of a population, and you collect facts about, you know, that sample. And then you strive to make what we call generalization to the population. So you look at the sample, and the sample can tell you a little about the whole population, right? And that's what statistics is all about, collecting all this data, right? Analyzing it and, you know, drawing what we call inference from it. Maybe I can talk about some aspects of statistics, you know. Data collection is a big part of it, data collection, right? Um, Even before you do data collection, right, you're supposed to do what they call your design, um, you know, the experiment or so, right? The experiment. You might need to design the experiment, know what data, Um, sometimes it's not always an experiment. It's maybe just a survey, right? You're doing a survey, right? All kinds of things you can do. Then you collect the data, right? Because you have to, well, even before this and all, that's what I'm saying. To put all of this in a few minutes is not easy. You'll have to design an instrument, design an instrument, design an instrument in case of a survey, right? And then do the data collection because lots of times you got to identify who you collected the data from and what data you're collecting and so on. And that's where your design, the instrument is going to come in. And when you get your data, and I think this is what we're going to just, I'm going to just introduce you to a little bit. You want to do what we call an analysis of data collected, right? And it is in this analysis that you kind of put it into two categories, right? There you talk about descriptive, and inferential stats, right? And in the descriptive part, what you try to do is you try to maybe represent the data using charts, etc. Charts, tables, that sort of thing, diagrams. You can also describe the data by numbers as well. And there's where we're going to do a little bit of this. This is what I'm going to focus on, right? We can describe the data with some measures, right? Or some numbers. And we're going to talk about something called central tendency, right? And that is going to be investigated by finding something called the mean, the mode, the median, right? And then there's some other things we call the spread of the data, right? The data. And to study that, you will have to find some things called variance, standard deviation, that sort of thing. Ranges. I'm not going to spell out all of these. These are too involved stuff, Yeah, and when you do all of this, you can be able to describe, you see the word descriptive, right? That part of statistics where you want to describe the data, whether be it by charts, tables, or you can do it by numbers, as I said. You can look at something called the central tendency of the data, as well as how spread out the data is, right? And here's where you get these things, variance, standard deviation, and you have like we call it range, interquartile range, the semi-interquartile range, all of that. We can't do all of that. Forget it. You have to do a whole couple of years of study to learn about all of that, right? And then there's inferential statistics now, where you draw conclusions, make inference, and draw conclusions. Right? And inference got to do with, okay, you're analyzing maybe a sample, and you are making generalization about the population based on that sample, right? You are inferring that, okay, if the sample behaves this way, well, then maybe that's true also of the population, you know? So maybe you take a sample of people in this country and you check how much money they're earning, you know? So you look at low income, middle income, high income, and you look at the figures, how much money they're earning, and you say, you know what? And if the sample is representative of the entire population, you can actually draw a conclusion about the population, right? Maybe you found out from your sample that almost 90% of Guyana, you know, is earning, let me say less than what do you call it, minimum wage. Well, then you can draw a conclusion and say, you know what, or make an inference about the whole population of Guyana, right? So maybe the samples are, maybe if 90% of a sample is doing that, right? And then you can say maybe you are right. That is true of the whole population, right? But that's not for you. You aren't there yet, right? You are well. You gotta study, make statistics a matter of study for a very long period before you can actually reach there, right? So we are not going to spend any kind of time on even, you know, using charts to describe data. I'm just going to give you a couple of examples, right? I'm just going to give you a couple of examples, right? I'm going to borrow from the notes I'm going to send me. So look at an example here, right? And again, this is statistics. So they say, well, okay, this is like a budget for a country for a particular year, right? So on wages and salary, they're spending 23 million. Health, education, agriculture, communication. They're spending all these monies, right? Maybe that's in the US. That definitely can be Canada. That's nothing. Yeah. So they want to, you know, see if they can put all of this information in what we call a bar chart, a proportionate bar chart. Mind you, nobody does these things anymore by hand. Eh? This kind of thing is done in Excel these days, right? So I'm going to throw up one of the bar charts that they're called proportionate bar charts. Right, so this is what it would look like. So how do you know, what size should represent communication, agriculture, education, health, wages, and salary, right? And what you have to do, you have to go to the table. Let's just say, all right, from here to here is a certain height, you know, I wonder what it is. Let me see. Just go back and see what they say. Okay. So according to this little the note in the textbook, they're telling you that the whole bar chart is 54 mm, right? 54 mm. 54 mm. So um, if you want to know, all right, education, they spend 15 million on education. So you put 15 over 90, because 90 is the overall, times 54 mm, and your answer is going to be 9 mm. So 9 mm, 9 mm from here to here, 9 mm will represent education, and so on, right? That's what it is. Don't kill yourself behind this. As I said, who does this kind of craziness now? All of this is done by computer, right? Nobody does anything by hand these days. All right, um, everybody does things using a computer, right? Just to give you a couple more examples, though, at least you can say we talked about it. So, okay. Okay, look at this one. So these are waterfalls in South America here, with various heights in meters, and they want us to, show the data on a bar chart, not a proportionate bar chart, right? So a bar chart. Let's see what they look like when you show them on a bar chart. One second. So that's what it looks like. Right. So I don't even know that Roraima had a waterfall. I didn't know. So you have a good idea. Just when we think Kaichor is this, top of the line or what, or the highest, look what's happening here. Kaichor is like the lowest fall in South America. Is that correct? And you see how they plot it and so, right? How they draw the bars. And the bar charts are well suited for what we call discrete data, or in this case, it's nominal data, right? Because each of these bars represent one of the falls. Notice their names are on it. And then the height here is the side here, right? Okay, let's take another one. Look at this one. So they're telling you how much money was spent on education in a certain country, and they want a chronological bar chart. What does that look like? It has to have some kind of time element to it, right? Or year. I'm gonna send you notes with all of this. Huh? So put this on a bar chart. That's what it looks like. And you can see that, okay, from 1989 to 1991, there was an increase, slight increases. And then after that, drastic cuts to expenditure in education. That is a bad thing. That's a very bad thing. Cutting the money you spend on education. You know? Let's take a last one. Maybe. And you've heard of pie chart? Pie chart. So let's say you're giving this. You're giving. So these are the number of teachers who graduate or who, yes, with these, in these subject areas from a training college, right? And if you want to put that on a pie chart, well, you'll have to make them a fraction out of the total times 360 degrees. So the total is out. I think when you add up the total here, total number of teachers is 90 teachers, okay, right? And if you want to know, well, how do you represent mathematics? You put 17 over 90 times 360 degrees. So the pie chart, whatever that turns out to be, I think the calculation shows 68 degrees. You will represent that with 68 degrees on the pie chart. Make sure what it will look like when it's finished. That's what it will look like, right? And when I give you the notes, you will always check to see, obviously they got all those angles in there, right? And this would very well show you, how many people coming out with these subjects. You can see physics, not very many, not very many. The lowest, right? Lowest number of graduates. Let's deal with one, what I call a line graph, right? So you have this data here. So I think earlier you had chronological data here, and we used the what is it? Chronological bar chart, right? But we're gonna do a line graph now. You're gonna plot these points on the y-axis while you put all the years on the x-axis, and you're gonna join them up, right? Join them up. Let me see the line graph on this side. Not seeing it. Hold on. 1 second. That's what your line graph will look like, right? From that data that I showed you just now. So 1986, you can read off 50 tons. 1987, 200 tons. 1988, 300 tons. So there was a constant increase. And then in the year 1991, a big dip. And maybe that was a year a disease hit. You never know. Disease hit. And the amount of bananas that were harvested went right down, right? And then, well, the farmers rebounded even higher than the 1990, right? They gone to 500 tons and they kept on going like that, you know? These are very, very important things, you know. When you see come the statistics, it helps everybody, business, helps governments. In the sciences, it's used quite a bit, you know, so that you can understand trends, right? Here you can see that sudden dip. You probably want to investigate what happened that year, why? You ask farmers, they say, man, they had a disease, right? Black fungus hit them, mess up their crop, you know? Yeah. And then there what you call frequency tables that you can also use. So these are all diagrams, right? And you saw them earlier, they were kind of captured in tables. And there's what we call frequency tables as well, right? So at times when we have data, we might use frequency tables to capture, you know, or a summary of all the information you collected. Let me show you what that might look like. So look here, you got 50 participants in some kind of competition. These are the scores that they scored. And all of this data might not make much sense until you try to put them on some kind of table, right? You put them on some kind of table. And let me show you what a nice table would look like. Let's see if I can make this a little small. Put a table right here. Right, so the table kind of start to help you make sense of the data, right? So how many of them score 0? You check through here, right? You will see 5 of them. And notice how they do the 5 when it comes to what you call tally. This is it when you tally them, right? 1, 2, 3, 4, and the stroke choose 1 as well, right? Now see that? So you count the stroke as 1 as well. So 4 with a stroke is 5, right? Keep that in mind. And look what it looks like. So you kind of get some sense that, you know what? How many score 0? You can pick out how many score 4. 4 points you can pick out very, very easily, right? You can get a total number of points and so, right? When you finish. So yeah. Sorry, this 50 is not total number of points. How many people were in the competition, right? Yeah, so that's an example of a frequency chart, right? Or a frequency table, right? Here, you notice the score are kind of discrete, eh? 0, 1, 2, 3, 4, 5, 6, 7. They have like whole numbers, right? At times you might not have whole numbers there. You might have like a whole range of numbers. Whole numbers, yes, but that captures a whole range, right? And you might have to use different ways of representing your frequency table, right? You want to do a little bit of reading. I'm going to send some notes. I'll send the whole chapter on statistics, right? And you're going to do a little bit of reading as to how we can represent data, how we can represent it using all these charts, frequency tables. You will just do a bit of reading, right? However, what we're going to concentrate on, and this is what I want you to concentrate on, right? Let me move this away. What I want you to concentrate on is measures of central tendency, right? And I'm going to include a video. I'm going to add on a video to this video. I'm going to add on, I think last year or a couple years ago, I made that video. It was a class I had. And I actually did a video on measures of central tendency and a little bit about the spread of the data. Don't worry with that part, right? Don't worry with that part. I might even chop it out too, who knows, right? But you don't go beyond it. Where I talk about the mean, the mode, and the median, right? And I did it for what we call raw data. Raw data. The reason why I did that is because most of the data analysis these days, the computer has so much power now that we don't have to long ago, you have to make up frequency chart and you have to group the data. And when you do all those things, you lose so much information, right? You lose so much information. Let me just show you what I'm talking. Look at this thing. If, let's just say, you're talking about scores, right? And let me say, people scored from, maybe in a test, from 0 to 100, right? 100. Shooting competition. Let's say in a test, a class test. Now you can write out from 0 to 100, right? And so what they attempt to do, they say, all right, from 0 to 10, from 11 to 20, from 21 to 30, and so on, right? And they'll show you, on the table, they'll tell you, okay, how many got between 0 and 10, maybe 5, between 11 and 20, maybe 10, and so on. But a lot of information is lost here because all you're seeing 5 between 0 and 10, but that doesn't tell you, well, maybe they all have 9 or up to 10. You don't know, right, whether these 5 people get not. It could be 5 people get not, or it could be 5 people could get 10. You don't know. That information is lost. So what is happening now? Is powerful computer programs are now in existence that would take the raw data, right? You see them tests where I give you all test one, test two, your raw scores. The computer actually take it and do an analysis of it, Give me all the charts and so on. I could take that data and analyze this class to see how well you all doing and so on, right? So there's no need for us to make up no frequency table and all of that. The computer will take the raw data and calculate the mean, mode, median, standard deviation, everything, the range, everything. At just the touch of a button, and you can get all that information. As a matter of fact, I spent an entire year, which year was that? 2022. Yes, I think from 2022 to 2023, studying a program named R. R. Right? They have plenty of others. They have Python. They got plenty of these are programming languages that you can use to analyze data very easily, very easily, right? And then they have what they call commercial packages, like people hear about SPSS. This is a very popular one that you can buy, right? The R and the Python are programming languages. SPSS is not a language, right? It's a statistical package that kind of all the commands are built into it. So you don't have to write code. You just put in the information and the people will do it all for you. So when you all do that test, I just take this spreadsheet, put it in SPSS, and SPSS do everything for me. With R and Python, so you have to write a little bit of code. Anyway, forget about it. I'm going to attach to this video here, as I say, a little, I think it's about half-hour video. Maybe more than that. Less than an hour. I'll attach it to this video so that you can, or I can put it separate now to save me some time. I'll make it available to you maybe between now and Wednesday. Yeah, maybe tomorrow. And you're going to watch that and concentrate on that, because I'm not going to test anything more when it comes to statistics. I'm not going to test you on all of that we talked about today. I'm only going to test you on mean, mode, median, a little bit on range and so, right? Range. Don't worry that part that deal with variance. Don't worry that part and what we call standard deviation. No, don't worry that, right? Just concentrate on these here, right? And you're going to learn how to calculate mean, mode, median from some raw data that is given. The video is going to walk you through all of that, right? So, yeah. What we'll do here, we'll stop right here.